Good afternoon. This is Jeff Mucci with RCR Wireless News. Thank you for joining today's webinar. Our presenter and sponsor is Corning, and our presenter is Jason Green, who is Wireless Program Manager for Corning. The topic today is the future of enterprise wireless networks. Before we get started, I want to go through a couple admin items. Firstly, within 24 hours, all the attendees and people who registered for the program will receive a link to a recorded version of this webinar. If you require or are interested in getting a copy of the PowerPoint presentation, please contact RCR or Corning. And at this point, what I'd like to do is launch a poll to get a feel for the audience. So we'll leave this open for 1 minute. The question that you should see is, which of the following best describes your company? Carrier, tower company, enterprise, equipment provider, or other? And we'll leave this open again for about a minute. It gives us a good feel for who's joining us today. Leave it up for another 10 seconds. About 75% of the folks have voted. Leave it open for another few seconds. I don't think we've ever got it, Jason, up to 100%, but we're getting pretty close today.
Good deal.
Okay, I'm going to go ahead and close the poll and share the results with the audience. Jason, I'm not sure if you can see this, but we've got 14% are carriers, including cable companies and mobile operators, 12% tower companies or neutral host providers, 10% enterprise, 37% equipment providers, and 28% other. So at this point, I'd like to introduce our speaker, Jason Green, who is Wireless Program Manager for Corning. Jason, take it away.
Thank you, Jeff. So today we're going to be talking about wireless and enterprise networks, and thanks for everyone joining. We're going to be talking about wireless beyond phones. I think if we think about what is critical in our life today, if we looked at this 10 years ago, it would say that I wouldn't leave my house without my car keys or my wallet. But today, I consider my smartphone, to be as important as that. And as a matter of fact, I thought it was funny yesterday when I was driving to work. I forgot my cell phone, and I ended up turning around to come back to my house to pick up my cell phone because I couldn't imagine, going a day without my phone, which just shows us how connected we are today. So we're going to talk about how our networks become more complex as the need for data continues to soar. We're starting to use more innovative and different techniques in order to address that need, and as that happens, our networks become more complex, and how do we handle that? We'll look at future trends. We'll see kind of where we were, where we believe we're going today, in terms of both Wi-Fi and cellular technology. I'll show a roadmap of different wireless technologies and show where we think they're going to be converging in the future. And finally, we'll look at key elements of the future wireless networks and what we believe is going to be key in order to support these new applications that we see today. Next slide, please. Okay. So this next slide does a good job of showing kind of a timeline of where we've been and where we're going. So if we look at this, back in the early 1900s, we really started connecting places. And when I say places, I mean buildings. So it was as early as the telegraph to the telephone to today. Around the 1970s, we started using optical fiber to connect buildings. And when we did this, we were connecting buildings. We typically have a demarcation point in the building. And depending on the size of the building, it's also very common in enterprise to have fiber going through the riser, connecting your telco closets. And if we look to today, there's about 500 million places that are connected via fiber. So it's something that's grown pretty increasingly over the last 100 years. If you progress the slide. So next we saw an inflection point, and we saw a really big increase in the slope of the line. So this is when we started connecting people. So it started in about 1983 when we had the first bag phones. So as many of you maybe can remember, you had a bag phone that typically you carried in your car or you carried it like a suitcase. and if you were like me, you tried your very hardest never to use that device because your boss would be yelling at you due to the charges. But we've really grown this, and it's really been quite an amazing ride. But today we have 7 billion devices, or 7 billion people that are all connected with these smart devices. The amazing thing about this is we actually have more mobile devices out on the market today than we have people in the world. So that means every man, woman, and child today has a cell phone. So it's pretty amazing. And with that, we've really started to see some pretty amazing statistics. So if I look at this today, the average 21-year-old has spent over 10,000 hours on their mobile device. Pretty phenomenal. That's over 1 year of their life. The mobile phone purchases have outnumbered births 9 to 1. 200,000 text messages are sent per second. 10 billion applications have been downloaded from iTunes. That's a whole lot of Angry Birds. 35 hours of video is downloaded to YouTube every minute. So these things have caused that slope to really become a vertical line. So it's really quite amazing. And what we see coming next is the wireless things that you see on the slide. So when I say wireless things, what I mean is day-to-day appliances. For example, a Coke machine in your office that's connected wirelessly that's telling the office manager that you're out of Diet Coke. ATM machine wirelessly informing the bank that they're out of 20s. Your washing machine letting you know that you have your clothes are dry. So you can imagine as we start to progress, and we see this trend to being very rapid, we're going to go from 7 billion devices to 50 billion devices. And when that happens, the need for bandwidth and the need to be able to scale with that bandwidth is going to be really critical. One thing I like to mention here when we talk about wireless things is if you haven't already done it, I'd recommend seeing the Corning Day Made of Glass video. This is a video that went viral last year with about 20 million views. But what's interesting to me, the main purpose of the video is really to show the technology of the glass displays and bendable glass and things of that nature. But as I view the video, I really see it in a different way. I really look at it to see, wow, all these wireless devices and all these wireless panels are going to have to be managed via wireless. So it's really going to show us, it kind of shows us the future of what we see things coming in the very near future. But in order to handle that, we need a very big pipe that can handle all of these wireless things and these new wireless applications. Next slide. So how do we handle all these new devices and these new wireless things? So what we believe is that the networks are going to become heterogeneous. We're going to have smart networks that are able to handle a big mix of technologies. When I say that, I mean 2G, 3G, 4G, but I also mean 802.11. And as we are right now, I think N is the common, but we're going to be seeing AC and AD very quickly, which we'll talk about in some coming up slides. We're going to have to handle active spectrum that changes. The carriers change spectrum and change bands fairly frequently. We have to have a network that can support that. And we're going to see new technologies such as MIMO. That is a technology that allows us to increase the throughput significantly. We're also going to have different bands that we're supporting in different technologies such as public safety, location-based services, the need to wireless medical telemetry as an example. So we're going to have a lot of new applications that are going to be going onto our networks, and we have to find a media that can handle that. When we look at our enterprise buildings, we're also going to always have to consider coverage and capacity. I think coverage is fairly obvious. As we walk into our buildings, we've come to expect the 4 to 5 bars on our phones. But as we design these enterprise networks, what actually is starting to become more important is capacity, meaning we're going to have to be able to scale to meet these the massive amount of data that's required as people are using their phones for more than talking. And these are going to need to be networks that are smart enough to work together and to work with different devices. And we've also seen the introduction of many different kinds of RF sources as we try to handle this increased slope that we saw in the previous slide. We're going to be seeing picocells and small cells, small femtocells that are entering into our buildings. We'll see distributed base stations that might be on the edge of our networks. So we're going to have to find ways that we can handle all of these pieces of equipment and have them work well together and not interfere with each other. Next slide, please. So as we look at trends, I think there's a couple of areas that we're going to focus on today. So we have cellular technologies. So we're going to have many cellular technologies that will be on a single network. So this includes our cellular, our Wi-Fi, and many applications. One story that I thought about on this one as I was preparing for this presentation is we just had my third child about 6 months ago, and when we had the child in the hospital, the first thing that happens after the child is handed over to mom is they put a wristband on the ankle, and they give mom and dad a bracelet. So this is our third child, so we've done this a couple of times now, but previously that bracelet was really just triggering an alarm if the baby left the floor. But in this particular hospital, they were actually running an application over their wireless infrastructure so that it could not only know where the baby was in the facility, but also if that baby was with mom or with dad or with a nurse. And so as we start looking at these different technologies, we're going to have all this on our same infrastructure. And we've seen the same thing. Bear with me, okay. We're going to see the same thing in other applications. In some very large public venues, such as football stadiums, we're starting to see where they have an option to give you a device or give your child a device as they enter into the stadium. And so after the event, if it becomes crowded and they get lost, they can actually track that via location-based services, and that is all happening wirelessly. We're also going to see a big spike in 60 gigahertz. So there's two big technologies that have entered the market in the last couple of years here, really last year, that both have a need for very high bandwidth, and they have a need for wireless. The first one we'll talk about is wireless HD. So wireless HD, really the big driver on wireless HD today is the replacement of your HDMI cable. So I don't know if you're like me, but in my living room today, I have a flat screen TV. I think most of us now have bitten the bullet and bought our flat screen TV, and I have that mounted on my wall. And so what I did is I took a Saturday and I had to weave my HDMI cable from one side of the room to the other side of the room. But what you're going to see in the future is a wireless connection. So that's going to be a 60 gigahertz link that's going to go from your control box, whether or not that's your high definition box or your Netflix box or your gaming console, that's going to wirelessly connect into your TV. In order to do that, we've got high definition TVs. The 3D TVs are coming out, so you need to have very high bandwidth. What 60 gigahertz allows you to do is allows you to get, in this case, 7 gigabits a second wirelessly within the room, which is something that's really quite exciting. We've also seen WiGig. So WiGig has already started to be introduced on the market. It's also called 802.11ad, and manufacturers are pushing this very strongly and already starting to build this into their chipset because it also provides very high bandwidth wireless. So the first applications we've seen for WiGig, which we've already seen some releases, is wireless docking stations. So if you look at your docking station today, I've got about a dozen cables that's leaving my docking station. They're going to my monitors. They're going to my different peripherals that are USB. So that'll all go away, and that'll become a wireless connection. And in the near future, we'll see that released with wireless access points. So now we're going to have very high bandwidth traffic that can cover in wireless. The interesting thing about 60 gigahertz is although it's very high bandwidth, it can't penetrate walls or obstacles. So one thing that both these technologies have done is they've introduced beam steering or beam forming into the technology, meaning on a 60 gigahertz connection today, we actually have a demonstrator in one of our facilities at Corning. If you step in front of the signal greatly degrades until it goes out. So it actually can't penetrate even the human body if you stand in front of it. But what you see once you activate beam steering, it can bounce around the room and always get to its destination, so you have a very robust connection. So when we're talking about data, that's going to be important. Next, we're going to talk about Wi-Fi. So Wi-Fi has gone from being a consumer-grade, kind of nice-to-have feature to being carrier-grade, kind of essential for our wireless networks. One trend that we've seen that's been quite interesting here recently is the carriers' adoption of Wi-Fi for offload of their traffic. So as we start to go into these buildings and as we start to have more and more users using their devices and being very data hungry, they're looking at any ways they can to offload that traffic. And Wi-Fi is actually a really good solution. And we're actually seeing the carriers installing Wi-Fi as well. So if you're in a stadium and you have 80,000 fans in your building, you can have the option of having some of them on the cellular network and have some of them on Wi-Fi. So next slide. So LTE Advanced is rapidly coming, and it's starting to become the the technology of choice for carriers. And the focus of LTE is around heterogeneous networks, meaning networks that allow load balancing between the different RF sources, meaning base stations and other RF sources like a femtocell, like a picocell, like a remote radio head. So the reason why this is important is it's going to allow them to seamlessly transition between the different technologies. So it'll allow you to go from 3G to 4G to Wi-Fi without any interruption. And so today, when you walk into a facility, you have the option of turning your Wi-Fi on or off, and many users will turn their Wi-Fi on to reduce their data costs. But now the carriers are also doing that. They're flipping that switch to allow them to take capacity off of their network, so it frees up capacity for other things. So that's something that we've seen. It's growing by leaps and bounds here over the last several months. What we also see when we look at LTE is when you have a building, you might have several different carriers in your building. It's not uncommon, especially in a public venue, to want not just one carrier, but maybe 3 or 4 carriers on your building. And these carriers will use different technologies to introduce their cellular. Some will use a DAS system with a centralized RF source. Others might choose to put that on the edge. And so when we do this, we need to make sure that everything works together and it works well. And LTE has a lot of new advances that allows that to happen. Next slide. Okay. So this slide goes back to 60 gigahertz and starts talking about the different applications we have for 60 gigahertz. So the first two that you see here is video, compressed and uncompressed. So this is the 60 gigahertz for the high definition TVs that we talked about previously. So this is that replacement of your HDMI cable. We're also seeing kiosks. So kiosks are actually something that have become quite popular, and we see this as being a big uptick for wireless. So if you go to the airport, they're going to have wireless kiosks that provide high definition video, and all these will work wirelessly via 60 gigahertz link. So you don't have to require a wire to go to every single one of these kiosks. So the only wire that you will have is really power. We've also seen this in a couple of metro areas at bus stops where they have very advanced high-definition screens that are working wirelessly as well. So it can tell you if your bus is late, or it can provide you traffic routes. It can stream video from traffic cams throughout the city. File transfer is a pretty obvious one. So you'll have very high-speed wireless file transfer, and this can be from your laptop to your network, but it can also be from device to device. So you can imagine you have your iPhone and you tap your buddy and you can transfer a very large file, or you could transfer maybe some family photos. I know now with the iPhone, I have so many pictures on my iPhone, I don't have time to actually manage them all. So this will be something that will be a very nice feature. And then we have wireless input and output. So this is the replacement for that docking station that we talked about, so that you no longer have to be toggled to mini USBs and having your monitors all connected wired. So now you'll be able to do all of this wirelessly. So it's really quite exciting. Next slide. So this slide is really about why 60 gigahertz. So why have the chip makers chosen 60 gigahertz to have this very high bandwidth wireless? Well, really, the reason's pretty simple. So one reason is that it's available. So if we look at this slide here, 60 gigahertz is available in all of the major developing countries in the world. So what chip makers can do is chip makers can choose 60 gigahertz, and they can use one chipset, and they are assured that this will work in all major countries. So what this allows is increased volume, and with increased volumes comes lower cost. So this is one of the big reasons why 60 gigahertz was chosen. Next slide. Now we're going to shift to Wi-Fi, and we're going to start off with a little bit of the history of Wi-Fi, and from there we'll build on where we see Wi-Fi going. So we started off with 802.11a, which was dual band and had some modest speeds, and then we quickly went to 802.11b. 802.11b was really the first wireless that was widely adopted. So what happened is we increased the data rates to 11 megabits a second, and this allowed wide adoption, and it also provided a substantial price decrease. So this is where we started seeing wireless access points in your local Best Buy stores. So if you build the slide. Next came 802.11g. So 802.11g was a big jump in data rate and range, meaning the distance you could be from that Wi-Fi access point. So here we started to see tri-mode products. So this is when we started to see wireless access points that could operate in both A, B, and G. So single products that could handle all three of these different wireless types. Build. In 2009, we introduced 802.11n. So 802.11n, so the big story around 802.11n was this was the introduction of MIMO, or meaning multiple streams, allowing us to have a massive jump in terms of our bandwidth that we had on these access points. So we jumped to 600 megabits a second, which again was also widely adopted. Then 802.11ac. 802.11ac really builds on 802.11n, but adds a couple of new features that allows for even more bandwidth. So the first was it provided more channels. The channel bonding went from 40 megahertz to 80 megahertz. We also improved the modulation. So we went from 64 QAM to 256 QAM, and we added more MIMO. So 802.11n had a maximum of 4 streams. AC has a maximum of 8 streams. So with all of this, we were able to get the speeds to 1 gigabit a second. Next comes 802.11ad. So 802.11.ad is the thank you. 802.11ad is the 60 gigahertz. And so what 60 gigahertz does is that allowed beam steering technology, which gave us very robust connections, and it massively increased the channel bond. So now we have a much wider area that we can use, and with that we got much greater speeds up to 7 megabits a second. The next slide. So this slide does a nice job of kind of graphically showing what we discussed in the previous slide. So if I look at this first bar, the yellow bar we see on the screen, this is 802.11n. So if you recall, 802.11n introduced MIMO. So this first build is the 802.11n as a SISO, or with just a single antenna. And you see we're just under 200 megabits a second. If we build the slide, now we add MIMO to 802.11n. So you'll see with MIMO, this technology greatly improves throughput. So now we're jumped up to around 450 megabits a second. Next, if we jump to AC. So AC, again, builds on 802.11n. And with those builds and the additional MIMO streams, we're able to get to over a gigabit a second. Next comes 802.11ad. So the first build here on 802.11ad is 1.4 gigabits, and this is representing 802.11ad without the beamforming or the beam steering. So again, this is without that robust connection. So because 802.11ad does not penetrate walls or your desk or your body, it's limited. But once you add beam steering to the technology, you're going to jump up to 7 gigabits a second, and that's the next build. Now with 802.11ad, the other thing that you'll see here, which is different than the other protocols, is it is really limited to a single room. So you have very, very high bandwidth, but it's within that room. And I think that's going to be the tendency that we're going to see going forward, is we have the need for a lot of bandwidth. And so what we're going to need is we're going to need to have more of these wireless access points, and we're going to need to get the user on a wire as soon as we can. So we can build to the next slide. So this is a graph showing the different wireless technologies as we kind of progress through the years. So this first one starts off with that bag phone I talked about in 1983. It progresses to today with LTE Advanced. If we build the slide, we'll add in wireless. And so when you have wireless here, you go from 802.11b in the 2000s to 802.11ad. Another interesting thing about this graph, which I'll just point out here, is you'll notice the slope really starts to increase, and that's with those 7 billion devices that we talked about. So this is when people started carrying around their phones. And the last build on this slide introduces the 60 gigahertz. So one thing that we find interesting is as we start to look at these different technologies, and we circle it here, So we have very, very high bandwidth, but we start to have very short ranges. So this is true with LTE Advanced, and it's also true with 802.11ad as well as the wireless HD. So what we believe is going to happen is we're going to have more wireless access points, and these access points are going to be getting you on a wire very quickly. So the goal is, as the wireless demands come up, as people become more and more data hungry, we're going to need to have these wireless connections, because that's something we know and love. But we'll be both the carriers and both the enterprise will want to get you on a wire as soon as they can. Next slide. So key elements of this wireless network, which we've gone over, I'll just summarize real quick, is LTE. So again, LTE Advanced, the carriers are quickly consolidating on LTE. That seems to be the winning technology. But as an enterprise, we're going to have to build networks that can support LTE. So it's going to be important that we support the core technologies that the carriers are bringing into our facilities. On Wi-Fi, the enterprise is really driving demand on Wi-Fi. But as carriers start to adopt Wi-Fi as well for their offload, the need for that Wi-Fi to be have a very large pipe and to be very, very fast is going to only increase. And finally, we have applications. So here we have, we mentioned wireless medical telemetry, but we also have location-based services, public safety. There's many, many applications that are evolving today, and they're all happening wirelessly. So as we look at the future of our connected life, as we look at that Day Made of Glass video and we kind of dream about the future, I think that future is going to be very close. And it's going to be really beyond our laptops and our phones when we think about wireless. It's going to be all those wireless things that we discussed in those previous slides. Next slide. Okay. So as an enterprise, how do we determine what kind of devices or what kind of sources do we want in our building? And so I think this slide does a nice job of kind of bucketing these different technologies. If I look at the bottom left, first I introduce femtocells. So femtocells are most commonly used today in residential. So you can go to your local AT&T or a local Verizon store and buy a femtocell today. And what that's used for is if you're in a rural area or if you don't have good wireless service, you can plug in your femtocell into your internet connection, and with that you can get you can get your 5 bars. The limitation of femtocells is femtocells can typically only handle a small amount of calls, so 8 calls or 16 calls depending on the type of femtocell you have. So it's typically not a good device for a large enterprise, but maybe it's appropriate if you have a very small building. Next we look at remote radio heads or picocells. Picocells can be kind of considered a beefed up version of your femtocell, but with the remote radio heads and the picocells, they are high capacity, so they really meet the need for data, but they are limited in terms of the number of bands they support and the number of the carriers they support. So if you have remote radio heads in your facility, you would have to have multiple remote radio heads to handle the different carriers and to handle the different bands that they're using. With Wi-Fi, we show Wi-Fi kind of starting off as your laptop and maybe your phone, but it grows very quickly. So what you see here is Wi-Fi kind of covering all 4 quadrants of this graph. That means Wi-Fi is really being used for a lot of applications. It's carrier grade, it's being used for offload, and it's also being used to handle all of these wireless things. So I think Wi-Fi is really is here to stay. If we build again, we have DAS, or distributed antenna systems. So a distributed antenna system takes these different RF sources and it centralizes them in a building and actually distributes those signals throughout an antenna system, which we'll talk about here in the next slide. So this building is representing a DAS and how it worked today. So if you look at this slide and you see the green, the blue, the yellow, and the pink, you can think of this as your different carriers. Maybe that's AT&T, Verizon, Sprint, and T-Mobile, for example. Maybe we have some additional sources that are being used for medical telemetry or location-based services or any other application that maybe we can dream up. But we take all of those devices and we bring them into what we call a DAS head-in. And so in this picture, we're showing that as multiple boxes, but it could be a single box even. The basic idea here is we're taking all of these RF signals and we're combining them. And once we combine them, we want to get those to travel on a fiber throughout the building. So if you build the slide, you'll see these pink lines. So now I've taken all my RF, I've combined it, and I'm traveling over fiber now. I've converted that, going from electrical to optical. And typically in a typical DAS today, that will go in from our main distribution frame to our telco rooms, and from the telco rooms, we'll convert that back to RF. We'll amplify it, and we'll push that across the building via half-inch coax and antennas. What we see happening in the very near future is we're going to be converting that coax, and we're not going to want it in that fiber in the closet. We're going to want that fiber to go into the horizontal as well, because as we talked about in all those previous slides, as 802.11ad becomes popular, as all of these wireless applications become mainstream, and as we continue to be tethered to our phones, the need for that high bandwidth is going to be important. So we're going to want to get that fiber as close to the user as we can. Next slide. So this is what we see every day, and it's always fascinating to me. But as we look at the different networks that we have deployed in our enterprise, we typically see that these are all separate networks. So we have our Wi-Fi network, we have our cellular network, and we'll have maybe a separate network that's handling any kind of specific applications that we have running wirelessly in our facility. If we look at that today, it really doesn't make sense. So as we build the slide, what we believe is really the future is one infrastructure. We call this total DAS, but what it really is an architecture that provides enough bandwidth to be able to support all of these technologies on a single infrastructure. So this allows you to simplify your architecture, allows you to simplify your installation, and provides that large pipe that can scale with the different applications that we're not even thinking about today. So the beauty with an architecture that's future-proof is you don't have to rip and replace it later. Next slide. What's enabling all of this is our data architecture. So what I like to think about here, and this is really the way I do think about it, to be honest, is I think of data as being a utility. So if I'm building a building and I think about the plumbing of a building, I don't build my building and put in a plumbing system that I think is going to work for 5 to 7 years. But the funny thing is, I think in a lot of our buildings today, we design our data infrastructure, and that's what it does. It lasts 5 to 7 years, and we end up ripping and replacing it. It really doesn't make sense. So what we really see in the future is an infrastructure that is fiber fed and that provides a massive amount of capacity so that you can scale with these different technologies. The carriers move very fast, so we want to have a media that can scale with them. We don't want to have Cat 5 today and have to upgrade to Cat 6 and then Cat 7, or have to constantly rip and replace our architecture. So we believe that fiber is that solution. This picture you're seeing here is actually a composite cable, which means that it has fiber for the capacity, but it also has copper for power. So this device, or this cable deployed in the horizontal, can not only provide you all the bandwidth you need, but it can also power those devices at the edge of your network. Next slide. So as we look at our fiber infrastructure, the benefits start to become pretty obvious. So in terms of a media, fiber is really the lowest insertion loss that you can provide. And if we think about this within the enterprise or an enterprise building, there really is no distance limitation. So we measure the length of fiber in kilometers, not in meters like we do for other media. It's very high bandwidth. So this is going to be the media that we're going to choose to provide the most bandwidth to any particular area in our building. It's immune to all EMI and RFI, so it's very secure. It's difficult or near impossible to tap. It eliminates any grounding considerations or shock hazards. It's very easy to install. You don't need to have a special technician to install your fiber. It has very high tensile strength. The fiber actually itself has higher tensile strength than even a typical copper cable, which is interesting. But this allows for very long pulls. Today, there's also been huge advances in fiber, especially with the rollout of fiber to the home a couple of years ago. So now this fiber is becoming very robust. It has very small bend radius, and in the fiber to the home type world, we even see people stapling fiber to the studs of their building. So it's not your fiber of yesterday. It takes up very little space. So when we go into these buildings and enterprises, some of the most precious real estate is actually the real estate in those risers. So when you have many Cat5 cables or many copper cables going into your riser, you can replace that really with a single strand of fiber or a single cable of fiber. So it allows you to really free up space in your riser. And then fiber supports all of your different applications: data, voice, video, building automation, process control. So it's really a universal solution. Next slide. So this slide does a good job of kind of comparing fiber to your traditional copper infrastructure that you might see today in an enterprise. So fiber is 99% lighter and smaller. So in this picture here, you see a Cat5 cable, but every one of those little blue dots would be representing more bandwidth that you're carrying over your fiber than you are with a Cat5 cable. So a single cable of fiber might have 12, 24, 48, even 288 fibers, and that's of roughly the same size of your Cat5 cable. Next slide, please. It's kind of a funny illustration of what we can do with fiber as we compared it to other networks. So if we look back in time to dial-up, to take the book Jurassic Park and download would take 27 minutes. As we move to a token ring architecture, it's 1 second. If we look at your basic 10 megabit Ethernet, 2.6 copies per second. If we go to fiber and we run 1 gigabit, we have 260 copies a second. We take that longer and we kind of apply it to what we've talked about in the previous slide. So let's say we've got a fiber that's handling a 60 gigahertz link at 7 gigabits. So now we've got a fiber-fed 60 gigahertz link, but that link is actually allowing you to go download 1,800 copies of this book a second. So it's really dramatic in terms of the speed that fiber can provide. Next slide. So as we wrap up, I wanted to I kind of compare this to the Dilbert that I have on my wall. I don't know how many of you are familiar with this Dilbert, but if I read it here, you've got the pointy-haired boss and your Dilbert who says, we won the bid to build a nationwide wireless network. And his comment is, then he states, how hard is it not to install wires? So I really like that. So as we've talked about here, and I think as a lot of us know that have installed these wireless networks, there are a lot of wires in wireless. And it's a lot more difficult than simply not installing wires. And so as we look at our enterprise networks, what we want to do is I think we want to try to build an infrastructure that is future-proof to handle all these applications today, handle those 7 billion phones, handle the future 50 billion wireless things that we have. We want to have architecture that is future-proof and that protects our investment. So I believe that's my last slide. So I appreciate the time.
Thank you. Yeah, that was a great presentation, great overview. Thank you so much. I too like the Dilbert, cartoon in terms of how difficult can it be really to install these wireless networks and or not to install wireless. But we'd like to open up for questions right now, and I do have a question I'd like to ask to start. First of all, we talked about wireless devices and applications driving the need for infrastructure upgrades to support these higher bandwidth demands. Can you expand on how you're seeing optical fiber being deployed in today's enterprise space?
Sure. So I think it's very common today. If we think of the enterprise, we're having we'll have fiber that'll go from the main distribution frame through the riser to the telco closets. But here recently, what we've also seen is a lot of fiber going to the horizontal. This is being done for a couple of reasons. It's being used to the early adopters of these solutions that are feeding fiber-fed cellular systems. There are a couple of DAS systems today that are fiber-fed in the ceiling. We're also seeing it a lot for passive optical LAN. Passive optical LAN is a big driver of fiber in the horizontal. And again, it's just the need to have this very high bandwidth media, which is really what's driving that in the horizontal. So where we see it today primarily is in the riser. Where we see it going in the future is the horizontal.
And can you talk about maybe some specific enterprise vertical markets where you're seeing greater adoption?
Sure. in healthcare, it's kind of interesting. In healthcare, I think early on there was a lot of concern, if I think back a couple of years, about using your cellular phones. You know, there was worries about interference with delicate devices, but now if we look at healthcare, it's one of the most bullish markets that we see. And it's really because they're starting to consider wireless to be a mission critical for some of these hospitals. So it's actually, in some cases, easier for the hospitals to get funding because they classify these systems as mission critical. And so, you know, because they have so many doctors today, and all these doctors are using smartphones, and there's so many applications in the medical field, we're seeing that as being a pretty a booming vertical. Another place I'll mention is hospitality. So we're seeing a lot of hotels where they're starting to bring fibers to each room, and again, it's for that same reason. When you go into the room now, they've got so many devices. You've got your different phones. I can't remember the last time I went to a hotel and I actually used my landline. You know, everybody's using their telephone. And if you go to a hotel, you've got you might have 100 rooms on a floor. So the need for that capacity is really starting to grow.
Okay. We have a question from the audience. It says, going from 3G to 4G MIMO systems, the previously deployed DAS systems have required a major overhaul. How are you ensuring the current DAS systems are future-proof?
It's a great question. So on a traditional DAS, when we go to MIMO, what that really means is we have two streams, and it basically doubles the infrastructure. So if I have a DAS system today and I have a single antenna, when I want to upgrade to MIMO, that means I have to double the amount of half-inch coax that run through my building. And of course, with half-inch coax, it's really a single-use media, so it's not something that I'd like to do if I could help it. So with fiber, what we're able to do, and we are doing this on some of our newer products today, over a single strand of fiber, we can handle both the SISO and the MIMO stream. And again, that's because of the bandwidth of fiber.
Mm-hmm. Okay, another audience question is, in enterprise environments, what is the need for an enterprise to build out an LTE solution as opposed to a Wi-Fi solution?
So I think really the need is for both. When you have an enterprise, you know, you don't know what kind of device is going to be walking into your building. And so I think it's important to both look at what the carriers are requiring or what you're going to need from a cellular standpoint, and then also Wi-Fi. Especially some enterprises, sometimes depending on the enterprise, the Wi-Fi might be you know, a private Wi-Fi. And since you don't know who's entering your building, and you don't know also who's toggling on and off the Wi-Fi as they enter their building. So I really think it needs to be a combination. But I think the key to that question is you need to have the infrastructure so that you can make those decisions as you choose. So the nice thing about having fiber in your horizontal is that allows you to make that decision. You know, if you have Wi-Fi today and you decide you want to upgrade to a DAS solution or to cellular later, you can do that, and you don't have to rewire your infrastructure. Okay, this question is from William. The question is, fiber extends the distance, but what about the power? Your composite cable would be a limiting factor when taking the fiber RF further to the edge. Okay, good question. So that is a good point. So it depends on the device at the edge. So one thing that we've been developing here is so when we think about composite cable and we think about bringing power into the horizontal, one thing that we like to look at and consider is the National Electric Code. So we don't want to exceed that 100 watts. So the way we handle that is we size our cables accordingly. So we always recommend that you over-provision your cables. So in the case of composite cable, we'd make sure we have enough fiber to handle multiple devices, and we would also have enough power to handle those multiple devices. The other things that we're developing is typically in an install today, if I think about this more in the DAS sense, we're using a 48-volt type power supply that's driving the electronics throughout the facility. And so we're also looking at ways that we can increase that voltage, which dramatically increases the distance. So for example, if I go from 48 volts to 60 volts, I'm over doubling my distances. So that's something that we're looking at today as well. That's a good question. Okay. Next question. One of your slides showed fiber through the riser to the telco closets in the horizontal. So the question is, in the horizontal support POL and a couple DAS RRUs that support fiber.
the question is, when you say you see more electronics for converged wireless and horizontal, do you mean that Corning is developing these type of fiber-fed DAS/Wi-Fi systems?
So we are developing new products. We'll be releasing new products here in the next coming months. But I think in this particular webinar, we're not focusing around products, but as a company, we are always looking to introduce new and exciting products. So I would encourage you to continue to look on our website and contact your Corning rep about that.
Okay. Next question: let's see. I'll paraphrase this. How your DAS can combine input from different carriers, Verizon, AT&T, Mobile, Sprint, and combining internal network. And the follow-on is a comment is, I see a lot of security issues doing that. How do you plan to address the security?
Good question. So the way we see this is, or the way I envision this working is you would have a dedicated link that would go to your RF or your DAS remote. And then for the gigabit functionality which is plugging in a lot of other active devices, I see that being on its own dedicated fiber link. So I don't see a place where we're combining Wi-Fi onto the DAS in the sense of that we're on the same fiber. I see it being the same infrastructure, but a dedicated fiber link for the gigabit type solutions.
Okay. Next question: how long do you see the current fiber deployed in the ground lasting, from a physical point of view and from a technology point of view?
So we have cables that were built in the 70s that are still in there today, and they're still working. So the nice thing about fiber is it does have a very long shelf life. We do guarantee fiber for all of our installations as long as it's by a certified installer for 25 years. But I certainly don't see. I mean, I do recommend. We didn't talk about the different types of fiber, but as we look at these buildings, I think single mode is becoming more and more prevalent as compared to multi-mode. But in terms of the longevity of fiber in the ground, I don't see that having any need to be replaced anytime soon.
Okay. Next question. You talked about enterprise customers building up their wireless and Wi-Fi LAN networks. The question is, how can they leverage their existing optical backbone and coexist to support cellular and other services?
So let me make sure I understand the question. So the question is, if you already have fiber today in your riser, how do you upgrade that for the future?
Well, I think it's how can they leverage their existing investment and their existing optical backbone while also supporting and coexisting with cellular and other services.
Okay, sure. So it is common today that if we're doing an installation and you have fiber already in your building today, we'll certainly leverage that, and we like to leverage that. So I don't see that changing. As we're starting to move fiber in the horizontal, depending on your building, if you're an early adopter and already have fiber in the horizontal, we could certainly use that. But if not, that would we'd be installing new cable. One thing that we do on these facilities, and it's something that we always recommend, is we always over-provision our cables. So if you need to have if you have a device in your telco closet, for example, you never run 2 fibers to connect that. You go ahead and run your 12 fibers or 24 fibers just to make sure that you're sized for the future.
Okay. This is a great question. Passpoint Hotspot 2.0 becomes when it becomes more prevalent and you have handoff between Wi-Fi and cell, how do you see the need for DAS as a mechanism to distribute WSP signals? Or do you see the need for DAS as a mechanism to distribute WSP signals going away?
I don't see it going away. I think it'll be a combination. I think in the future we'll have many different network elements that are wireless, and I think they all have to work together. So with LTE Advanced, the carriers are going to be able to toggle that switch between Wi-Fi and their cellular network, so they'll be doing that without us even knowing it. And at the same time, today users will turn on or off their Wi-Fi depending on their wants and desires. So I see all of these things working together in a network.
Okay. Just scrolling through the questions. We got a bunch of things that came in. By the way, if we miss one of the questions that's been submitted, Corning will be receiving a copy of all these questions, and we will they'll be addressing those offline. Next question, can you comment on whether the wireless service providers are going to fully support 802.11x over DAS, which is not intended to help their backbone or backhaul?
So personally, I see the Wi-Fi. I see it on the same infrastructure, but I don't see it riding on the DAS, if that makes sense. So previously we've had products where Wi-Fi did ride on the DAS itself, and when that kind of lost traction was with 802.11n when we introduced MIMO, and the reason for that was with the half-inch coax we just couldn't support that much bandwidth to cover the DAS and also cover the Wi-Fi. So where I see it going in the future is I see an infrastructure which has got enough fibers to handle both. So in the platforms that we're seeing in the future, I expect that you'd have one fiber that's for your cellular services, and you'd have another dedicated fiber link for your gigabit Ethernet services.
Okay. Many of the other questions tend to overlap a lot of the things that we've already talked about, so or they're kind of hard for me to fully appreciate. But I would say that we're pretty much at the end of the questions that we've got coming in. Let's take a break and let some more questions in come in. Jason, do you have any other comments or points you want to bring up or amplify from the presentation?
Sure. I just appreciate everybody's attention. It looks like we had a great attendee list here. I want to thank RCR Wireless as well for putting this on, and I would encourage you, if you have any questions, to contact RCR Wireless, which will feed those back to us, and I will be sure to cover any questions that we didn't cover over the webinar today and feed those back to RCR Wireless. So thank you. Okay.
Well, at this point, I'd like to go ahead and wrap up early. I think we covered a lot of ground. We've got a lot of questions that did come in. Many of them overlap, so it's rather than ask redundant questions, I'd like to go ahead and wrap up the webinar now and thank the audience for joining us. Jason, great job on the presentation. I would like to add that if you're interested in receiving a copy of the presentation, please send RCR or Corning a note. Within 24 hours, we will be sending a link out to all the people who registered and the attendees. The link will go to a recorded webinar for your viewing on demand. And again, if you have any questions, please let us know. So thank you again, Jason, for your time, and thank you, attendees.
Thank you.